Hello, everyone. Welcome to the webinar on how to start an impactful DevSecOps initiative. I'm Priya Chawla, Director of Product Management at ShiftLeft, and joining me is Ethan Lightstone, our VP of Product Design.
Good morning.
Great.
One moment. Are you sharing the app or the whole desktop? Because I see dark. Oh, there we
go. Sorry about that. I hope everyone can see my screen. So today we want to talk about what are the characteristics of new modern software development and how traditional application security has been mostly human intensive. What are the challenges of application security in this modern world of development? What are the DevSecOps requirements for the new software development world? How does ShiftLeft help you with DevSecOps? We'll do a demo of ShiftLeft and walk you through a data leakage assessment that we have for all the attendees of the webinar, followed by Q&A. What do we mean by modern development? So when we think of modern software development practices, automation comes to our mind as a primary thing. And when we think of automation, CI, or continuous integration, and CD, which is continuous deployment, are the two acronyms that stand out. Continuous integration is all about testing automation, so to make sure that any new changes do not break your application. And continuous deployment ensures that any of these changes, as they pass all the stages of your deployment pipeline, can be released to your customers. So you can go to a phase of agile development where your developers can focus on building new features and their features can go live soon after they've stopped working on them. Build faster, failed faster, which is being able to run automated tests against a new build. So when a developer makes a change, a new build is triggered and tests are run to avoid the integration challenges that typically happen if you wait for too late in the cycle to merge your changes for a release. And last but not the least, to get the benefit of a hybrid cloud environment, which means you get the efficiencies of public cloud, and you also are able to use your private cloud or your private data center for your mission critical applications on a need basis. Traditional application security has been human intensive. Let's look at what are the approaches that have been used in the development, build and release, and production phases. So the first approach that comes to mind is code analysis. Code analysis has been around for over a decade and was designed for traditional monolithic applications and to run on an analyst laptop. So it was okay if code analysis would take several days or hours to run. But today, this is no longer an option because most organizations and customers we are talking to are releasing several times a week or sometimes several times daily. You would typically run automated QA tests in your build and release phase, and these tests would rely on the knowledge of people building these tests and the time it would take to build these tests. So again, if you're releasing several times and if your release frequency is much higher than before, then your automated tests just can't keep up because it's no longer a problem that it's much beyond the scope of a human. In production, you would typically deploy technologies like IDS and WAF. IDS, which is intrusion detection system, was a threat-based approach. So it would treat your application as a black box, which means you have to know, you have to codify the threats into signatures and constantly tune the IDS for new threat patterns. And web application firewall, which was historically used in production to monitor runtime, generated a lot of false positives. And so it was mostly employed in alerting mode and not as much in blocking mode. And organizations that try to use it in the blocking mode actually ended up blocking a lot of legitimate traffic because of the huge amounts of false positives that were generated. And so both these approaches, which is web application firewall and IDS, had to be constantly tuned and took a lot of time to get to a point where they worked for your scenarios. And that was okay if you're releasing a couple times a year. But in the new scenario of releasing several times in agile development, this approach no longer works. And the last but not the least, pen testing. Pen testing, most companies that we've talked to do pen testing at most 1 time a year or a couple times a year because the amount of effort it takes to triage the results of pen testing is huge. And even if you've prioritized the issues that you've identified through pen testing, you still need to remediate those issues, and developers need to find the line of code that contributed to that issue in the first place. So this effort as well is very human intensive. AppSec challenges in modern software development. The first thing we've already touched on is faster release cycles. Now we've gone from releasing a few times a year to several times a month or sometimes several times a day. And these release cycles mean your traditional security tools do not work out of the box with your CI/CD pipeline and the frequency of the releases that you want to strive for. As you move from monolithic to microservices architectures, data flows, which is data flowing in and out of these services, visualizing those data flows has become very complex. And each microservice has to be protected very specifically for its attack surface, which means the very objective of moving from monolithic to microservices, of making these microservices very lightweight, is actually defeated because the overhead of running the traditional security tools on these microservices is very high. The third primary challenge is application is now the new perimeter. Gartner has quoted that the attack surfaces are now shifting to the application. You no longer control the network in the server. The only thing you're responsible for is protecting your application and your data. And last is GDPR and other compliance regulations are now expanding the definition of critical data. So if you traditionally, we've treated credit card numbers, social security numbers as critical data that needs to be protected. If you read what the definition of critical data in GDPR regulation, it includes things like photos, posts on social media. So now the scope of what needs to be protected has significantly increased. And also businesses that have to watch out for these regulations has increased. As an example, again, GDPR, it not only means you need to, it doesn't matter where your business is located. If you're working with EU resident data, you need to address this regulation. The DevSecOps requirements that you should look for in a solution when you're working on this initiative at your organization are the first most important, a comprehensive continuous security. Operationally efficient, should be automated just like your DevOps pipeline is automated, should understand the data flows for your applications and microservices, and it should have a low or minimal production overhead. So let's look at continuous comprehensive security. Modern software is increasingly assembled rather than developed from scratch. So it includes your code or your custom code that you're writing, which is serving your business need or specific to your business vertical. You're increasingly using third-party libraries and open source software to accelerate areas of your code that are not contributing to innovation. So you increasingly want to use off-the-shelf open source software for certain parts of your application. And you're talking to more and more external services. So your application or microservices are constantly talking to external APIs. And what does comprehensive security mean? It means protecting your application, which is protecting the code in your application and all the third-party libraries and open source components in your application against known vulnerabilities. It also means protecting the same software against unknown vulnerabilities, again, in your code and in open source and third-party components. And you have to achieve that for every version of every microservice. So again, for every release that you do, you want to ensure that you have a comprehensive security solution in place. Operationally efficient. The key challenge with traditional solutions was the amount of false positives they generated and the amount of effort it took in terms of time and money to sift through those false positives to get to the most critical issues that need to be addressed, and then to minimize the time it took from understanding what those issues were and the time it took to fix those issues. So for the new DevSecOps initiative, you want to make sure you're highly operationally efficient. So the solution should be precise, because imprecision would defeat any comprehensiveness. And false positives essentially elongate the remediation process, which we talked about with respect to code analysis and traditional WAF solutions. Automated. The traditional security solutions do not work well out of the box with your automated CI/CD pipelines. But for DevSecOps to succeed, you need the security solutions to be automated from the ground up, which means it should work for every release, because when it comes to manual solutions, you will always have to trade off between operational efficiency and achieving comprehensiveness. And it will take a whole bunch of time, and you may not be able to keep up for every release. So automation is the only way in which you can achieve the first two requirements that we talked about, which is comprehensiveness and also being operationally efficient. The fourth primary requirement is understanding data flows. What do we mean by data flows? Now, data is the new currency. Do you, in your organization, have visibility into what data your application is handling and how this data is flowing throughout your application or microservices? Let's look at an example. You have a customer who's sending a social security number to a microservice, essentially in your organization, which is a part of a mesh of microservices. And these microservices are talking to databases and persistent storage buckets. Now you add a third-party integration with Splunk because your developers need more visibility to triage. You add other integrations with Salesforce and marketing. Now, as you add these more and more integrations and you're talking to external services, what is happening is data is starting to leave your boundary. Now, data could be leaving on legitimate paths, or data could be leaving on paths that are not legitimate, which means these paths are either not approved or the data is leaving in an unencrypted or unencoded manner. So having this visibility into data, which is your new currency, becomes very critical from a security standpoint. So that's one of the primary requirements of DevSecOps. And last but not the least, low production overhead. If you had a choice between performance and security, you would tend to choose performance because you would not want your user experience to be degraded severely such that it impacts your customers. So you don't have to make a trade-off between performance and security. You want to keep the production overhead as minimal as possible, so your infrastructure cost don't increase significantly and your user experience is not impacted. Now that we've established these requirements for DevSecOps, let's look at how shift left can help you in your DevSecOps initiative. What shift left does is it extracts the semantic graph on your software. And we'll touch on what we mean by semantic graph in just a second. Once we've extracted semantic graph from your software, we create a security DNA from this graph, which informs a micro agent running in production of what vulnerable paths are there in your application and what to observe for at runtime. And this micro agent is looking for real-time runtime issues and real-time exploits, and is able to give you more actionable feedback as to which issues you need to prioritize when it comes to addressing issues in your code, because now we know which issues exactly manifested at runtime. So let's look at the requirements of DevSecOps and how with shift left we address that. The first requirement was continuous comprehensive security. Now, when we create this security DNA, we essentially are looking at all known and unknown vulnerabilities in your piece of code. And we're looking at your application and all the open source dependencies that are being used in your application, and tying the context of how these dependencies are being used and creating a comprehensive semantic graph and a security DNA profile. Because the micro agent is informed of this DNA, it's very precise in where it's instrumenting your application, and as a result has minimal or no production overhead. And because we are observing the application at runtime, we know exactly what code issues have caused a problem at runtime. We know where you should prioritize your issues. So you no longer have to sift through false positives. You have much more actionable feedback to take back to your developers to fix those issues. What does semantic graph mean? So your application typically consists of an application logic, which is serving your business need. It's using one or more open source dependencies. It's developed using a web framework and running on a virtual machine. And again, the examples here are Java. And we create a graph, which is a novel representation of your application in a graph data structure, which is trying to understand what does the code look like in your application? How is this code executed? And what data is used by this code? And so we create this graphical representation of your code, which combines all these layers together into one dense graph. Once we've created the graph, we extract the application DNA from that graph. And what do we mean by DNA? DNA essentially includes one or more entry points of your application, and these entry points could be sanitized, they could be authenticated or not authenticated. So we identify all of those characteristics of these entry points. We identify one or more exit points of your application, and we understand if these exit points are approved or not, if the data is leaving in an unsecure way, or if the data is encrypted or encoded. We understand the open source dependencies being used by your application and what vulnerabilities in this open source are actually being triggered by your app, by the context in which your application is using these open source dependencies. We understand all known and unknown vulnerabilities in your application, and we understand the data leaks, which is again identifying sensitive data in your application and how that data is flowing between the entry and the exit points. So once we've extracted this application DNA, the micro agent that's running with your application is informed of this DNA and is observing your application at runtime to give you a lot more actionable feedback. So what is the benefits for developers? You no longer have to deal with false positives. Vulnerabilities are confirmed by production data. There's a much lower mean time to repair, because now you know exactly which vulnerability was triggered in production and what line of code caused that issue. How does it help DevOps? It's fully automated. You no longer have to write thread signatures. You no longer have to tune this solution. It's fully automated for your CI/CD pipeline. It's highly performant, so you no longer have to trade off between performance and security. The micro agent that's running with your application is very precisely instrumenting the application, and the runtime overhead is insignificant. And how does it help security people? Again, it's fully automated, so you can actually secure every release without slowing down development. You have comprehensive runtime protection. You understand the data flows in your application and what sensitive data is being handled by your application. And you no longer have to manually sift through false positives. You're only alerted on vulnerabilities that are actually confirmed by production usage. At this point, I'd like to hand over to Ethan, who's going to walk us through the demo.
Sounds good. Okay, I'm going to unmute my side. And you have to mute your mic. Perfect. Okay, so hopefully everyone can hear me, and I'm going to share my screen. Change presenter. Main screen. All right, so you should be able to see my screen now. And okay, what I'll be doing is walking you through the shift left user experience and kind of demonstrating some of the topics that Priya had just mentioned. So I've logged in, and at this point we're looking at the main shift left dashboard, where we see all of the applications that we're currently analyzing and monitoring from a security standpoint as these cards. And so what I'll do today is go through a specific security use case which is happening inside this test application called Hello Shift Left, which, as you can see, there's some red here, so clearly there's some issues that need to be resolved. So I'll go into the application, and what we're looking at now is the app summary view for this application called web application called Hello Shift Left. And I'll walk you through some of the elements on the screen here. But one thing I want to point out right away is, as Priya had described, right, there's two insertion points for this security solution. One is at the code level where it does analysis as part of your continuous integration process. So there's an integration with Jira, and we have a plugin that does the analysis of the code. And then at runtime, it's continuously monitoring for security problems in real time, and those two data sets are effectively blended in this experience. So what we're seeing here is, starting with this top application throughput chart, is the throughput generating on this app right now. I'm triggering that manually in my browser. So we're seeing that activity, and we're seeing throughput as well on what we call triggers. So these triggers for a web application are basically going to look like web routes. So in this case, you kind of see URL patterns here. But really, for any software, triggers effectively mean that these are the calls into the app that cause logic to happen or data flows to happen. And so what we see from code analysis, if we focus on this violations widget in the middle, is from the code analysis, we see that there are 60 discrete places in the code where an SQL injection attack is possible. And we see 127 locations in the code where sensitive data leaks are possible. But at runtime, what we've detected in terms of real activity on this application, that there are 53 actual data leak incidents that are happening. So we're going to dig into that to get into more detail, and I'll continue to sort of walk you through this screen. So I've described the throughput chart for this application, which is looking at the past hour of data, the triggers on the left-hand side, and finally on the right-hand side, we have this panel called data destinations. So what this is doing is it's summarizing sensitive data as categories that we've detected from code analysis, and showing that these sensitive data categories are being saved to different data sinks. So in this case, you can see payment data and tokens are being saved back to the web, HTTP, and we can actually track how much is this actually happening in runtime. And furthermore, we see other types of data, payment data, password data, medical, and so forth, and these are being saved out to the log file. And as you can imagine, this is highlighted as red because, as an example, payment data, if it's being saved as plain text out to a log, would be considered a sensitive data exposure. What I'm showing right now is purchase data going out to this debug file. And what I was pointing out earlier was this app summary view is effectively like an analysis experience, which is entirely driven by filters. So what I've done is I've clicked on purchase data as a data category, the data destination is a debug file in this case, before it was the log. And once that filter is in place, what we're looking at now is on the left-hand side, these are web triggers that invoke the data flows that are causing this leak to happen. It's listing in the middle the individual, what we call violations. Violations are effectively individual problems that we either detect from code analysis and or runtime. So in this case, it's both. And on the right-hand side, we can see the actual Java variables in this case that have been categorized as purchase data. So in this case, there's a payment class and an account class. And in this case, they're going to the debug file. What I'll do is now drill into this particular payment class. So the class is payment. The instance name is payment. So the class was initialized as a payment object effectively. And when I drill into that, we're now at sort of the lowest level of depth that you can see from the shift left analysis, where we're now looking at, again, payment data going out to the debug file for this particular, purchase data, but for this particular object called payment. And so what we see from left to right are the exact data flows that we can see are causing this payment object to leak to the debug file. So if I click on one of these triggers, we get down to a level of visibility where you can see individual lines of code. So, so if I could describe this from left to right as a data flow, what we see is the trigger itself, which previously was named by a web route, is associated with a particular object and method. So the object is the account controller with the create method, which is effectively triggered from the web. The data source in this case is not this accounts DB for the first flow, because when we're creating a new account, we're receiving those parameters from the web. And then this is the initialized object. So the instance is called payment for the data type payment with these sensitive attributes inside of it, credit card number, billing address, and so on. And then this instance is leaking out to a debug file. And so what's cool is, if I mouse over this, you can see the purple highlight on the panel below showing me the exact line of code where the trigger happens. And of course, if I mouse over the right side, I see the actual line of code at the bottom here, print writer, print line, which is inappropriately saving this payment object out to a file. So this is a pretty powerful use case because as we've described earlier, as Priya had described earlier, by doing this sort of data flow analysis, we uncover what you would think of as typical security vulnerabilities like SQL injection, cross-site scripting vulnerabilities, and so on, as well as detecting activity that could leverage those vulnerabilities to make an attack. But as a result of doing that kind of analysis and looking at data flows and looking at the code level the names of the variables, we are able to automatically categorize what sensitive data you have in your various applications, and then be able to detect when something bad is happening with that data as well. So another lens into all of this is just through the management of alerts and the violations themselves. And this is probably how, from a process standpoint, you would triage this stuff. So I'll show that to you now. If I return to Payment Manager, and so we're back on kind of an operational view of this. Once I got to the data flow, you could kind of imagine that's more of a developer-centric view. So once I'm back on Payment Manager, another lens into all of these security issues is if I click onto this little symbol here, which signifies that there are alerts. So in other words, any issues that happen in an app can trigger an alert. And within those alerts, so I'll just click on one of these alerts. You have the summary of the alert, in this case, injection vulnerabilities, and below that, individual violations. So violations are effectively going to be grouped by an alert based on sort of a natural grouping logic. So in other words, if a particular app has a whole bunch of security issues that have been detected as a result of a recent deploy of that app, for convenience, we bundle all those security issues, which we call violations, into one alert. And then we provide several controls to decide what to do or assign these violations to individuals in your organization to go fix. So if I click on a violation, now we get to this level of detail about the violation. So this is all sort of a very different lens than the app summary view, which is more operational. This is more about triage here. And once we go down to this panel, we still show you the lines of code involved in this particular issue. So I'll return here. That's pretty much the extent of the demo that I'd like to do with the shift left product UI. So I'm gonna pass the proverbial mic back to Priya, and she'll manage any questions that are coming up at this point. So we'd love to take your questions, and I'm going to mute my microphone.
Thanks, Ethan. Hello, yes, so I wanted to go over a data leakage assessment that we have. So we are offering a free data leakage assessment for all the attendees of the webinar. And what you will get with this assessment is discovery and classification of sensitive data in any of your applications that you want to try this on. You'll get visibility into data flows for these data elements. This will give you an insight into how ready you are for GDPR compliance, and you'll get a report specifically for GDPR. And it'll also show you all known and unknown vulnerabilities in your application. You should also receive the link to sign up for this data leakage assessment in the chat window. Or you can go to this link, which we will share with all the attendees after this webinar. At this point, I'm going to move to questions. Feel free to send us questions in the questions panel. I'm going to start going over some of the questions we've already got. The first question is, who is the audience for using shift left? Is it security, DevOps, or engineering? I'd love to have Ethan answer this since he's super passionate about personas.
Yeah, happy to talk about that. It's obviously difficult to anticipate for all organizations, which kinds of roles would do different things in your product. But the way that we have been thinking about this is we don't believe that there's a lot of tools out there that facilitate really healthy collaboration between engineering, operations, and security. And so we like to think that our experience will provide that kind of collaboration. What I suspect would happen is the security team would be more involved in defining the policies that determine, the alert severity levels or what is considered a data leak and what is not. So although that would work out of the box, organizations have different requirements for these things. So the security team would manage that policy. The people who I would expect to be using the app on an ongoing, basis, watching it in production in particular, in my view, would be operations or DevOps or DevSecOps individuals who are responsible for, maintaining production software. And then finally, obviously, when code level issues need to be resolved, I would expect developers to get involved at sort of a later stage if something needs to get fixed. I would say, the happy median would be somewhere around DevSecOps because they would be the ones using it the most in sort of the ongoing way.
Great, thanks. The next question is, what is the impact on my runtime speed? So there is very minimal impact on your runtime performance, and we've been constantly benchmarking this against application performance monitoring tools and other RASP tools, and it varies from application to application. But what we've seen in a typical application is the runtime performance the impact is 1/5 to 1/6 times lesser than any of these other security tools or application performance monitoring. The next question is, my team releases daily. How quickly can you detect a new leakage? So since we are fully automated and we are a continuous security solution, which means every time a new release happens, we'll create a semantic graph specifically for that newer version, and we'll extract the security DNA from that semantic graph, and the micro agent will get a new DNA that it needs to observe for at runtime. So the detection of a new data leakage should be instantaneous. Did you have anything else to add to that, Uchan?
I do not.
The next question is, do you integrate with any bug tracking tools? Currently, we do not integrate with any bug tracking tools, but this is on our very short term, this is on our near-term roadmap. So this should be a feature that should be coming out very shortly.
I could add to that in just that I think the integration site, like the obvious place that I would assume we'd want to integrate is at the violation and alert level. I'm not sure if that was clear in the question, but
yeah. The next question is, where does the name shift left come from? The name shift left comes from our vision and belief that eventually all security problems arise from code. So we need to enable the security persona and the DevOps persona to shift security to the left in their pipeline. And that's our inspiration for shift left, which is shifting security left. The other question is, how do you detect what is sensitive data in my application?
Yeah.
Do you want to take that, Ethan?
I can take that one. So the way that we detect sensitive data, I guess I'll start by drawing a comparison, which is a lot of the tools that we've investigated. What they attempt to do is at the network perimeter, or at least closer to the app, but the network to the app, they try to inspect the contents of traffic flowing into the application, identify what patterns they see that may look like a credit card number or may look like someone's email address. In particular, that can introduce a lot of overhead. And as we can see, fairly frequently credit card numbers can be mistaken for things, and vice versa. Things like GUIDs can look like credit card numbers, so there's a high rate of false positives there for that kind of detection. Our approach is effectively looking through the source code while doing the data flow analysis. I hinted at this a little bit during the demo. What we can do is just look at the names of the variables defined by the programmer, and we use a natural language processor to automatically catalog those variables by some standard categories like PII and medical and so forth. As you can imagine, there will always be cases where your organization may have a very specific name for certain variables in the code that you consider sensitive that we were unable to classify automatically. In those cases, you can always augment what we call the policy of shift left, which would then allow you to manually say, okay, this is the name of the variable. I'd like to classify this as PII, and from that point onwards, it would be classified that way.
Great, thank you. The other question we received is, does shift left consume significant system resources? So like I mentioned before, the overhead on system resources, CPU, memory, is fairly lean. So it's very minimal overhead, depends on varies from application to application, but the applications we've been testing against, it's like I said, less than 1/5 or 1/6 what you would see of a typical agent that's running on your application.
Yeah, and just to add, like what Priya's defined, what Priya's talking about is like an application performance monitoring agent. So if you've ever used New Relic or App Dynamics, there can be significant overhead in terms of the instrumentation that it does in runtime. In our case, as she pointed out, it's minimal compared to that.
How are you the next question is, how are you generating security DNA of a version? Could you please provide more in detail? Do we need to integrate any plugin into our applications?
Yeah, this is a great question. Sorry, Priya's signaling to me, so I'll attempt to answer this. So yeah, there are two integration sites. One is the agent, which we've just talked about. which is in the case of Java, effectively running with your app as a jar inside the JVM. And that's what's monitoring stuff in real time. The security DNA and a lot of the heavy lifting of the analysis is done by analyzing the source code. We call that the plugin. What is our official term for that? Is it plugin?
It's a plugin for your CI tool that you use. So if you're using Jenkins or if you're using Travis or TeamCity, we have a plugin for your CI pipeline, and it's triggered at every build. So it's a post-build step, and that extracts the semantic graph of your application, on top of which we generate security DNA.
Right. And so it's effectively like a command line tool running alongside the build environment.
So the next question is, how can I sign up for the data leakage assessment? So we will send out this link to all the attendees of the webinar, and so you can sign up that way. So that's all the questions we have today. Thank you everyone for joining the webinar.
Thank you very much. It's been a pleasure.